Lesson 3. So this one is talking about we talked about essentially when you get to Math 30, we just did it. Translations are up and down movement, okay, and left and right movement, okay. Now we're going to talk about the shape change, the stretches or the reflections of graphs in terms of how the parabola curve is skinnier or wider, or what makes it flip up or flip down, okay. Well, sorry, just flip in general. It doesn't flip up versus flip down. Okay. All right, so let's go ahead and look at these here. So we're analyzing the graph of y equals a times x minus p squared when a is greater than 0. So we're going to look at these two here, 2 of f of x and 1/2 of f of x. So when it says f of x, don't get confused. They're just saying put this there. So that just means it's y, oh, there it goes, y equals 2 times x minus 2 squared. And this is y equals 1/2 times x minus 2 squared. Okay, if you want to take a step and put in your graph calculator, you can. Just put 1 in y1, 1 in y2. Okay, just to stay on the page, I'm going to go and just sketch it. So you can kind of just do it with a couple points, though, even. Like, I can just plug in a point to kind of see what's happening. So I can plug in 2. Okay, 2 minus 2 is 0. 0 times 2 is 2. So it's still going to have the same vertex. So the vertex didn't change. That spot didn't change. Okay, but let's put in 1 now. 1 minus 2 is a negative 1. Negative 1 squared is positive. 1 times by 2, 2. So when I go to 1, I'm going to be at 2. So you can already see it just kind of went a little bit higher on the line that was already there. Okay, well, let's try 3. 3 minus 2 is 1. 1 squared is 1 times 2 is 2. It's symmetric. We expected that, right? Okay, because here's the axis of symmetry. Those of you guys are gone yesterday, axis of symmetry is what cuts the parabola in half. Let's just do 2 more points, one on each side here. If I put in 4, 4 minus 2 is 2. 2 squared is 4 times the 2 is 8. So if I go here 3, 4, I'm all the way up to 8 this time, so right there. Let's get it right for me here. Okay, and if I put in 0, 0 minus 2 is negative 2. Negative 2 squared is 4 times 2 is 8. So at 0, it's also 8, which we expected. They're symmetric. So this is what the 2 one looks like. You can see it's skinnier. It's steeper, you could say. It's growing faster. Okay, we'll talk about what we're going to call that here in a second. Okay, if you do the 1/2, okay, so for this one, we'll just kind of do the red. With the 1/2, if we put the 2 in, you still get the 0, so it still shares this spot. All of them are going through that spot right there. Okay, let's put in again. Just going to put a couple points here. I'm going to put in, this is 2, so I'm going to put in 3. 3 minus 2 is 1. 1 squared is 1 times 1/2 is 1/2. So it's going to be here, like right there at 1/2. See how it's just outside of it? It's getting a bit wider. So it's going to be the same thing on the other side, right there. That'd be 1, because 1 minus 2 is negative 1. Negative 1 squared is 1 times 1/2. Okay, let's do 2 more points. If I put 0 in, 0 minus 2, negative 2. Negative 2 squared is 4. 1/2 of 4 is 2. See, it's definitely on the outside of the parabolas we have, so it's definitely wider. And then if I do 4, 4 minus 2 is 2. 2 squared is 4. 1/2 of 4 is 2 again, so we're here. So this is what this one looks like. It's coming out here. Okay, so that one got wider. So the thing I want you to notice is 2 is bigger than 1. It got steeper. 1/2 smaller than 1 between 0 and 1, and it got wider. So when it says this, complete the following by circling the correct choice and filling in the blank. Compared to the graph of y equals f of x, the number 2 in the graph of 2 of x results in a vertical expansion. It's expanding faster, so it's getting steeper, okay, by a factor of 2. So it took the original graph, and every point on the original graph is times by 2. Okay, so it's expanding it. That's what's happening, okay? Every point here, so this point here was 1. What's 1 times 2? 2. Okay, this point right here is 4. What's 4 times 2? 8. So every point is being multiplied by 2. Okay, good. The y-intercept of the graph of 2f of x is this is going to be multiplied by 2 as well. Okay, is double, because we times it by 2. So the y-intercept originally was 4, and then it got to be 8. 4 to 8. So you're seeing the changes in the y values is what's important. Okay, you're seeing the changes in the y value. Okay, go and get that. I'll leave it here for a second, then we're going to talk about the other one, what the other one's called, which you can see it's going to be compression. Okay, I'll kind of explain how a way to, in my mind, a way to remember the two. Okay, all right, so you're going to lose this. So let's just get to this part D here. Okay, so it says compare the following circling the choice to fill in the blank. So f of x with the number 1/2 in front results in a vertical compression by a factor of 1/2. And so how you can remember the difference between the two? Expand, think about expand as it's getting steeper faster. Compression, think about you're pushing on the parabola and it's making it fatter. So you're kind of compressing it, making it wider. So compression's wider, expansion's steeper. Okay, that's what you can kind of think about when you're talking about the two. Okay, the y-intercept of the graph is half the y-intercept of the graph of y equals f of x. So it was 4, now it's 2. Okay. Okay, so in mathematics, the general name given to an expansion or a compression is a stretch. So you can call expansion or compression a stretch unless I'm asking you to be specific. Okay, a vertical stretch is anchored by the x-axis, so the x-coordinates don't change because you're stretching the y's. The x's stay the same. Okay, describe the effect of the parameter a on the graph when a is bigger than 0. So it causes a vertical stretch. So when you have something in front there, it gives you a vertical stretch. Okay. What's that? Because that's how they're changing. So like all of our y's that we just did on that graph, there's what changed, right? So that x-intercept stayed the same, but then it was the first one went from 2 to 4, and then 2 to 1. So the y's are changing. So we're changing these graphs vertically. Okay, so just, you know, we have a regular parabola. If it's expanded, it's going to have the same x, but it's going to be steeper because the y values are going faster. And then if it's a compression, it's going to be wider because their y values are going slower. So that's kind of what we're looking at. We're going to do a lot more with that too, Joel. So if you still need a question, we can do that in a second. Vertical stretch by a factor of a. So whatever a is, that's your vertical stretch. Okay, if you get good with this stuff, it's really going to help you. Like I said, Unit 2, Math 30. We just took a test on that today. Horizontal stretch gets tricky, but we're not doing that. So, all right, let's keep on going here. So let's look at the negative now. Okay, analyze the graph when a is less than 0. So rewrite the equation. So we're going to rewrite negative f of x. So we're going to write y equals negative x squared, and we're going to write y equals negative 2x squared. Okay, you guys put those graphic calculators fine. We're just going to sketch them together. Essentially, if the negative's out in front of the x squared, is the negative being squared? No, the negative is not being squared. Okay, if it was, it'd be bracketed, right? So only the x's. And so what this does is everything you square is going to become negative. That's what it's doing. This negative is just saying everything that you're doing is going to be negative. Well, if that's the case, then our normal x squared graph is all in the where? Positives, so the negative x squared puts it all here. Just flips everything. It's a reflection. And so it looks like this. Pen will draw here. There we go. That's what negative x squared looks like. It just simply flips over or about the x-axis. That makes sense, right? Because our vertical stretch, we hit all of our y's by 2, right? Or 1/2 previously. So what are we hitting all our y's with now? A negative. So look, right here, At 1, I'm at 1. Well, what's 1 times negative 1? Negative 1. At 2, I'm at 4. What's 4 times negative 1? Negative 4. So it just keeps flipping all your y's across the x-axis. Okay, notice my x's are still in the same spot. We didn't move left or right at all, right? Okay. And so what's going to be different about negative 2x squared? What's that going to be? Right, and so it's still going to flip, but it's going to be that steeper guy we just did. So that one we did from before that was skinnier flipped, because it's negative 2. So the negative 2, we can plug points in too. If you need to put points right now, and to make this make sense to you, let's do it. Here, let's just do a couple. I'll just keep doing 0. I'll do negative 2, 1, 0, 1, and 2. I'm talking about x values, okay? So let's just do this real quick. Negative 2 squared is 4 with a negative. That's negative 4. So the point negative 2, negative 4 is right there. Okay? Negative 1. Negative 1 squared is 1, negative. Negative 1, negative 1. It's right there. 0 squared 0, negative is 0, so that stays at 0. That's why it's sharing this point. 1 squared is 1, negative 1. That's right, it's right there. 2 squared is 4 with a negative 4. That's why it's right there, okay? So that's where those points are coming from. So now, if I just, we actually can steal this. If I do a negative 2 now, what do? I just times all these values. Yeah, by 2, because these already got hit with the negative, right? So the negative's already on these ones, but we could do it again. It doesn't matter. Here, I'll do it again. That's fine. One more time. These are x values. Okay. Negative 2 squared is 4. 4 times negative 2 is negative 8. So I'm going to be at negative 2, negative 8. Right? No. Negative 5, 6, right there. Okay. Negative 1 squared is 1 times negative 2 is negative 2. Right there. Sorry, I shouldn't have done red probably. Here, we'll switch to yellow real quick here. Okay, 0 squared 0 times negative 2 is 0. That doesn't matter. It's that same dot there. 1 squared is 1 times negative 2 is negative 2 again. And then we get the negative 8 again. So you can see this is the negative 2x. So it's the same one we just did from before, but it's flipped. Okay, the same exact skinny expansion, right? That's still an expansion. Okay. What makes it an expansion? It's bigger than the number 1. Anything above 1 will make it skinnier than what you have. Okay, if you want to call it skinnier or steeper, okay, whatever works for you. Any questions at all? Okay. All right, cool. All right, complete the following first. The first row is done. So we're going to go ahead and go through these. So equation representing, so that just means what is it representing? This is y. Let's get off of yellow here, sorry. Let's go to black. Y equals negative x squared. Notice on all the ones we did, the vertex didn't what? Didn't change, right? Now, here's a tricky one. Y equals x squared has a min at 0. What does y equals negative x squared have? The one we just draw. Max at 0. Very good. Max of 0, or at 0, 0. It's fine. Axis symmetry doesn't change. Okay. The transformation was reflect over the x-axis. Okay. So this one, y equals negative 2x squared. Vertex is the same. Okay. And we have max min value. So our max min, the max is 0 still, because it flipped. X equals 0 for AOS. Didn't move it at all left or right, so it's still right down the middle. This would be reflect over x and stretch 2. Okay? Reflect over x and stretch 2. Okay? Now you can be more specific and you can say expand 2 if you'd like. Okay? Okay, for a, f of x, where a is less than 0, so that we just know that's going to be ax squared. We're still going to have the same vertex. that means we're going to have a max at 0 because it's flipped. That's flipped for sure because it's saying A is negative. Same here. And you just say reflect over x-axis and stretch by A. Yeah, because it's saying A is less than 0. So it's telling you A is negative. I know it doesn't look negative, but it's telling you it is. Okay, good. Okay, so you just got your Gavin. We're talking about reflections. What makes the graphs flip? Okay, a negative out in front makes the graphs flip in front of your x squared. Okay. All right, so let's finish at the bottom of this page here. So how is the graph y equals negative x squared compared to the regular? We've just being redundant, right? It reflects over x-axis. And if you want to put it, that means vertically. Sometimes people get confused because it says x-axis. They think that's horizontal. It's over x-axis. So if you have your x and y, x-axis is here. It's over this. So it's vertically flipping, right? People get confused with that in Math 30 especially. Compare the graph of y equals x squared versus y equals ax squared when a is less than 0. Results in a. We're just going to say, yep, again, redundant reflection in the, they say x-axis, like I said, yep. And a vertical stretch by a factor of A. All right. Okay, so we're going to summarize this. I'm going to do a couple examples, and that'll be it. So your goal for today is to get down stretches and reflections. Okay, from standard form. All right. So here's everything we got. So compare the graph y equals x squared. The following transformations are associated with the parabola. Okay, A indicates a vertical stretch. So whatever A is out in front there, that's a vertical stretch. A is bigger than 1, you get the expansion. So 2, 5, 10 makes it steeper. Between 0 and 1 is a compression, so it makes it wider. Whenever A is less than 0, you will reflect it. Okay. P indicates, remember, we kind of think about this backwards, but P indicates the left and right movement, opposite of what you see. Q indicates up and down movement, like Brett was asking earlier, that's going to be what you see. So if it says on the outside there, if that says +6, that's just up 6. Okay, don't do opposite there. Okay, vertex is P and Q, and then x equals P, or whatever your movement right or left was, that's going to be your new axis of symmetry. So now we're going to put it all together here. Okay, so consider the function 2 times x plus 4 squared minus 3. State the transformations applied to the original x squared graph. So one thing you want to notice, and we're dealing with parabolas this unit, so we're going to be primarily dealing with these. But as soon as you see a square like this, just generally in math, that means quadratic. Okay, that means you're going to have an x squared, right? Because I'll FOIL those out, I'll get an x squared, and we'll show you how to do that in a couple of lessons when we undo standard to get to general. But my point is that when you see a square, you guys are like, oh, that's quadratic. Okay, if it didn't have a square, let's say, then what type of thing would it be? What type of function? No? Linear. Yeah, be a line, because there would be no squares, right? So just in general, so you guys understand that. But we're dealing primarily with squares, okay? So here it is. Say the transformation. So just anybody, just go ahead and popcorn it. What is the transformation you see? Anyone, I don't care which one. Left 4. Okay, good. Left 4. Left 4 down 3. There you go. Expansion by 2. Okay, that's all your movements for that graph. You're going to move that graph from 0, 0. You're going to move it left 4, down 3, and expand it by 2. Okay. Okay, so we're going to look at an issue you can run into here that's really, really important, so pay attention. So Marika and Curtis were discussing how to graph the function out using a graph calculator. Marika suggests doing the stretch followed by the translation. Okay. Curtis suggests doing the translation followed by the stretch. So we're going to do what they said. So Marika said she's going to do the stretch first. So expansion of 2 would put her at, another thing you guys can do that's actually really easy If that's at 1, what's 1 times 2? 2. That's at 4, what's 4 times 2? 8. You can just kind of do it like that, too. You don't have to keep plugging it in. You can use the graph because you know you're multiplying all the y's by 2. And then we know it's symmetric. And so that's what it's going to look like after she stretches it. So that's what she did. She stretched first. Okay? And now she's going to do the translation. So the translation of left 4, down 3. So 1, 2, 3, 4, 1, 2, 3. So hers is there. That's where her spot is. And I know it's over 1 up 2, over 1 up 2, over 2 up 8. And so this is where her new graph is. Okay, so that's what she got. So let's see if Curtis's is different. So Curtis translated his first. He went left 4, down 3. Right? Is that what he did? Let's make sure here. Yep. Okay. So left 4, down 3. Okay, and so what happens is when he's stretched, he's stretching all of his y values, right? So see how this is -4, -3? We have to times that y now by 2. So what's -3 times 2? -6. So it pushes his vertex not where it's supposed to be. Because you have to times all the y values on the stretch. And so his is now looking different than hers. And so then what happens is it's going to be, his is going to be down here. Whoops, sorry, I'm off my pin. There. We're down 6, so there, and there. Okay, so Curtis's, is not right. So anybody want to take a guess, or just what they think of why Marika's was a better option? Anybody want to take a shot? Why is hers right compared to this? So obviously, the order mattered, right? Because them doing different orders gave us different answers. So think about that. It's kind of a hint. They could, depending on where you move to, though, right? So yeah, that's a good idea. So he said the signs will change. You're doing translations first. They could. Okay, so Brett, you're saying it pretty close, So what Brett's saying is that he moved the original, then stretched it, rather than move the stretched. So he's saying what I'm going to kind of give you as the answer, but the reason it's the answer is stretching is a operation of what? What are you doing to stretch things? We're multiplying, right? In translations, we're doing what? Adding, subtracting. What comes first with the order of operations? Multiplication. So you always do stretches first. Okay? So you want to write that down. We got to go stretches, reflections, then your translations. Okay? And I think that's coming up here in a second. You might not have to write it down. But because these are multiplications, I'm putting X for multiplication. These are plus or minus. So order of operations, right? Same thing. So that's what was the difference there. Okay, perfect. I think it's right here. Yeah. See, there's the steps for you. You don't have to write it down. It's right there for you. Okay, stretches, reflections. All right, so a couple examples, and we're done here. This last page. Okay, so describe how the graphs of the following functions relate to the graph of y equals x squared. Okay, so first thing is this one's ready. So this one, is there any left or right movement for A? No. Is there any up or down movement? Nope. It just has a vertical stretch or compression. Compression of 1/4 and a reflection. Because of the negative. The negative makes it reflect. 1/4 is the compression. Why is it a compression? That's a fraction smaller than 1. When you do 1/4, it's going to get wider. If you do it in your calculator, you'll see that it gets wider. That makes it a compression. We don't like this 1/3 in the y, so I'm going to multiply this 1/3 over to the other side by hitting it with a 3. Y equals 3 times x plus 6 squared. Okay, 3 times x plus 6 squared. So what are my movements? Left 6. Not up 3. Expansion 3. Up 3 would be over here, plus. But good. Like I said, that's how we learn. Expansion's 3. It's an expansion because 3 is bigger than 1. So it's getting steeper. That's going to be even steeper than the 2 one. That's an expansion. Is that what you said? Yeah. Yeah. No reflection. Okay. These are good kind of SAT diploma question right here where they say, what's T going to be? Okay, test question. All right, we've got 3, and then I think 4 is the last one there, yep. Okay, the following 3 transformations are applied in order to the graph of y equals x squared. A reflection, a vertical stretch of 1/3, and a translation 7 units right. At the end of the 3 transformations, the point 1t is on the resulting graph. Find the equation of the image function after each transformation. So what they want to know is essentially, what is the new function that made all that happen from the y equals x squared? Okay, so what that means is, if you're lost, we know we have a reflection, so that means I have a negative here, right? We know we have a stretch of 1/3, and we know we're going 7 units right. There's nothing out here because there's no vertical move, so that's your function. Does that make sense? Okay. Ooh, good one here. What is the coordinate of the vertex? We haven't really been talking about the vertex today. What's the coordinate of the vertex for this guy? Close. 7, 0. Okay, because guys, our vertex always starts here. That one's vertex is what? It's 0, 0, right? So your vertex is going to be your left and right movement. Okay, we moved right 7. Right 7 means plus 7 to the x. So 7, 0 is your vertex. Okay, any questions of that? Now that's why Curtis was wrong, because his vertex changed with the stretch. Your stretch is not going to change your vertex. Your left and right will, okay? Your stretch is going to always kind of maintain the same vertex. Because remember, when we stretch here, when we did 2x squared versus x squared, did we have the same vertex? Yeah, all of those graphs are coming from 0, 0. Okay, so when you stretch, it's not going to move your vertex, okay? All right, find the value of t. So what I want to know is, plug 1 in to your function here. What's the value of t? So we got 1 minus 7, negative 6. Negative 6 squared is 36. 1/3 of 36, negative 1/3 is negative 12. So t is negative 12. Yeah, they like doing stuff like that where they're saying, what is t after this graph did these moves, where was, they'll say like, actually what they will say is, the point 1, 1 is now where when you do these movements. And so all you got to do is make the new function, plug in the x to get your new y, right? Because 1 squared is 1, right? And so that's what they do quite a bit. Okay. Yeah, I'd say it's a medium question, but a lot of people miss it because it's comprehension, because they're not sure what to do with it, right? So, yeah, so 6 squared. So how did I get 6? Because I put in the 1 here. 1 minus 7 is negative 6. Yep. Okay, all right, last piece here, guys. Hang in there. Okay, so complete the following table. So what's the vertex? This is where you should look at this right away. I'm going to go ahead and pause the video. I want you to kind of almost give yourself a self-quiz right now. Okay, I'll let you get a freebie of domain and range if you're not sure on that yet, but these three should be solid. Okay, these three sections here: vertex, min, max, and axis symmetry. Give yourself a little self-quiz here and see how you can do. Okay, I'll give you about 2 minutes. We got vertex. So we got this one's vertex is what? -3, -4. Okay. If you're wondering if the reflection affects that, no, because we'll reflect first. So that reflection, we're still at 0, 0. So if we do this reflection from here to here, we're still there. And now we're going to move left 3, down 4. So we're still going to be there. Okay? Max min value is always going to be the -4. It is a max or min? It's a max because it's a negative, right? So it's a max, -4. Your AOS is always this value. X is -3. We'll do domain and range last. What's the vertex for the second one? 9, 0. Good. There's no vertical movement, so that just stays 0, but we did go right 9. Good. Is it a max or min? It's a min, right? We didn't flip, so it's still min. And what is the min? 0, that value. Your AOS, 9. Okay? So your domain's the easy one, guys. Parabolas domains are always going to be XER because they don't have any problems with what X can be. So that's the one that's automatic. The range is what changes based on where you moved. Okay? So for example, you want to look at your max and min, right? If my max is -4, my range is less than or equal to -4. Because it's going down. The parabola is going downwards. Okay, if my min is 0, that means my range is greater than or equal to 0. Okay, and that is it.